So I already have a chart set up with two moving averages. And so the question is how to set up a requirement, a number of bar requirement prior to a crossover. All right, so what we want to identify, is a crossover of two moving averages, but only when the faster moving average has been below or above, right, the slower moving average for a minimum of 10 bars. So for example, basically we want to eliminate these two crossovers here, right? Because there hasn't been, or I should say the moving average hasn't been on one side of the other moving average for more than 10 bars, right? So yeah, this question kind of sounds like an attempt to, eliminate these whipsaw actions here, that we got right here, these multiple crossovers, right? So the two crossovers inside this triangle we want to get rid of because there hasn't been a minimum of 10 bars of the faster moving average being on one side of the slower moving average. So yeah, all right, so that's our first question to get us started. So let's get BloodHound open and let's put in today's file name. All right, so there we go. We have a file name started here. And let's see, let's go straight to the logic tab here. And let's make a new logic template. Okay, so let's give this a name here. All right, so we're looking for a minimum of 10 bars before a crossover occurs. So, all right, so let's do the easy part, which is the crossover. All right, so I'm just going to use an indicator crossover solver. Put that there. Let's connect that up. And let's see here. I have an SMA 14 crossing over an EMA 55. So, all right, there you go. So there's a name for this crossover. And now I'm just going to plug in the moving averages. So the SMA 14 is already there for us, right? It's the default indicator here. And so input B, let's switch that over to the EMA. All right, there's our EMA. Change it over to the 55 period. And there we go. All right, so there's there's a couple of crossovers there. Yeah, there you go, some more crossover signals there. So let's go back over here, right? So essentially, we need 10 bars. What's being asked for is 10 bars between crossover signals here. So what we're going to do is we're going to grab a comparison solver and we're going to compare, right, the fast moving average to the slower moving average. Like so. And let's see. And let's give this solver a name first. SMA 14 to the EMA 55. So again, input A, it's already set to the SMA 14. Don't need to do anything there. So let's just go down to input B and switch this over to the EMA. And there it is. Let's change the period to 55. And we're done. Okay. So now we have this, right? So we can simply see, right, when the SMA is below the EMA, we're going to get a short output and vice versa. And let's compare that to the crossover signals here. So let's mark a couple of these here. There, got them marked. And let's take a look at the comparison again. Right. So, you know, when we're looking at the comparison, we can see that just prior to the crossover, we're getting short signals here. Excuse me. But the crossover signal is going to be long, right? So if we're making a filter, you know, the filter needs to agree with the final signal, right? And that final signal is going to be a long, you know, cross up signal. But we have a short output from the comparison solver. So what we need to do is reverse the outputs here. Let's just switch these outputs like so. Right there. Okay. So now we have a long output prior to the long crossover signal we want, right? And then in here we have a short output prior to the short crossover signal that we're looking for. Okay. So, all right. So now we have the comparison solver kind of set up. You know, the output is basically in alignment with the crossover signal that we want. Now, to do the 10 bar, to check for the 10 bar requirement, we're going to use the look back. So this solver can simply, you know, look back 10 bars and see where there are 10 bars in a row, you know, that were all long, that we had a long output for 10 bars in a row. So, so we're going to put 10 in there. And for the mode, right, we're looking for a minimum of 10 bars. Right, a minimum of 10 consecutive bars to be more precise. So, and then also, here, let's stretch this out a little bit. Right, you'll notice that the signal is actually occurring, right, on a short output. So we need to take the, let's see, we need to take the long output, right, that's happening on this bar, and shift it forward 1 bar, right, onto the signal bar. Right, so we need to take all these long outputs and shift them forward again. You know, and the same thing's going to happen, right, with these short outputs, right? This short output, right, we can see it stops 1 bar before we actually would get the short signal. So we need to take these short outputs and again shift them forward 1 bar onto the signal bar, right? So basically all the signals or all the outputs from our comparison solver need to get shifted forward 1 bar so that they line up with the signal. So, yeah. And also what the look back can do that as well. So we're going to use the displacement function here. So actually let me turn off the look back. I'll just set that back to 1. And we can just take a look at the displacement function here. Right, so with our displacement set to 1, right, we can see now all the long outputs match up with the long crossover signal, and all the short outputs now match with the short cross down signal, right, and you know, so on and so forth. So, all right, so that was the displacement function. Now, just as a little side note, if we didn't want the displacement, we would just set it to 0. Right, and then everything's back to normal. Right, so basically right now the look back node is doing nothing. So with a displacement of 0 and a look back period of 1, the look back node isn't doing any kind of function. Yeah, so with the displacement of 0, we can see that basically the outputs are 1 bar off from the signal bars. So, all right, so let's shift this again. So let's put that 1 back in the displacement, and our look back period, let's set that back to 10, and we see the mode is minimum. All right, and so now if we take a look here, all right, we can see that, well, prior to this long cross up, right, we had 10 bars where the slow moving average was below the fast moving average. I'm sorry, the fast moving average was below the slow moving average. So we had 10 bars of that, right? But this short cross down, we only had a few bars, right, where the SMA was above the EMA. It was only a few bars in here, so there's no output, right? Output's gone here. And actually, it just so happens that I guess we're keeping this signal here. So let's adjust my triangle. So it looks like this long cross up just had the bare minimum of 10 bars, right? So this, so the SMA, the fast moving average was below the slow moving average for 10 bars exactly, just enough where we actually got right, an output on the signal bar here, right? So there we go. So basically these two nodes make up that 10 bar requirement, or that 10 bar filter. So now we just connect them together with an AND node. Like so. All right. So there's the crossover signals, and now we connect our filter in, and there we go. The short cross down disappears. So, all right. So that was it. This first one here was pretty straightforward, simple to accomplish. Let's see if any other signals got rid of. So yeah, it doesn't look like it. Looks like my moving averages I chose don't cross a whole lot, and there just really isn't any serious amount of consolidation, I guess, with the RTY. So let's see. Yeah, all those made it through. All right. Well, anyways. There. There we go. Okay, well, that does it for the first question there.